Okay, today's lesson is lesson number 84. We're going to be going back to geometry a little bit here and talking about some special triangles, so specifically special right triangles. And we're going to get into our trig unit, starting out with the acronym that you guys probably learned in geometry of SOHCAHTOA. So those would be your trig ratios, okay, the trigonometric ratios that it says here. That's talking about sine, cosine, and tangent. Ratio being the fractional part here. So sine is opposite over hypotenuse, etc. Okay, we'll get to those. So here we have two right triangles. Okay, this would be the 45, 45, 90, and then a 30, 60, 90 triangle. Okay, and remember these have the special properties where in the first case we have the two legs being congruent, and then the hypotenuse is the length of a leg multiplied by root 2. Okay, so we can think of that as x root 2. Okay, then over here in our 30, 60, 90 triangle, we have the side across from 30 degrees is the shortest side. That one we call x. The hypotenuse is twice that length, so 2x. And the longer leg is x times the square root of 3. Okay, so we have x root 3, and 2x for our key values there. Okay, so let's try some of these. For instance, if we were just given a side length of 4 for number 1 and the angle 45, we know, first of all, that if this is angles 45, this one must also be 45. Okay, it's a right triangle. So and the interior angles have to add to 180, so that has to be 45. So we have the 45, 45, 90 triangle here. We remember for these that the two legs are both x and the hypotenuse is x root 2. So that means this leg over here must also equal 4 since x equals 4 from the first leg. And the hypotenuse must be 4 root 2. Okay, for number 2, if we're given a hypotenuse of 3, this is a 30, 60, 90 triangle. Again, this must obviously be 60 if that one's 30. And it's a right triangle. Okay, so we label with our the values with the variables. So we have x root 3, and 2x for the 30, 60, 90. The 2x is the hypotenuse side. The short side is x, and the longer leg is x root 3. So since 4 equals 2x, I can solve for x by dividing by 2. That means that x equals 2, so the short side has a length of 2, and the longer leg has a length of 2 rad 3. Okay, so with these you want to start by labeling with the variables with the appropriate ones. So either x root 2 or x root 3 2x. Okay, so whatever, if it's one of these special triangles, you can just label them that way. And then whatever number they give you will give you an equation like it did here. You solve for x and then plug it in for the other two values, or the other two places where x is. Okay, so moving on to some more examples of these. In a 30, 60, 90, what if I have a short leg of 3? Well, that's just x. The hypotenuse is 2x, and the longer leg is x root 3, so this must equal 6, and this must equal 3 root 3. Okay, over here we have x, and x root 2. That means that 2 is equal to x root 2. So I solve for x. I'm going to divide by root 2 since this is being multiplied to the x. Okay, so think order of operations. To undo the multiplication, I need to divide by that number. So dividing by root 2, I get x equals 2 over root 2. But we need to rationalize the denominator, so I multiply top and bottom by root 2. Okay, remember this is just a fancy version of 1. And I can always multiply by 1. That doesn't change the value. Okay, but multiplying by the reciprocal here clears out that square root. So I just have 2 root 2 over 2. Okay, again, down here in the denominator, square root of 2 times square root of 2 just gives me 2. You can think of this like square root of 2 times square root of 2. That gives me the square root of 2 times 2, right? We can combine under multiplication. We can combine square roots under multiplication. So I'd have this. That's just the square root of 4, which equals 2. Or you can think of it like square root of 2 times square root of 2. Well, that's just the square root of 2 squared. Right, I have 2 copies. And when I'm squaring a square root, I can cancel that out, so that way I just get 2 as well. Okay, so whatever way makes more sense for you to think about this. Okay, but I do get 2. Since I have a 2 in the numerator and in the denominator, I can reduce. Okay, now this root 2, I can't reduce with this, but I can reduce these. Okay, so I simplify and I just get x equals root 2. That means that the short side must be, or sorry, that each side here, because it's a 45, 45, 90, each side must equal root 2. Alright, number 5, I have a 30, 60, 90 again with a hypotenuse of 2. If I label my sides, the short one's x, the other leg is x root 3, and the hypotenuse is 2x. I can solve for x. I get x equals 1. So the short side is 1, and this is 1 root 3. Or we can just write that as the square root of 3. Okay, so make sure you guys are writing these all in your notes if it's your first time watching the lesson or you missed part of it in class. These are all key examples to have in your notes. Okay, 6, 7, and 8 are here now. These ones all have a hypotenuse of 1. So these triangles are going to end up being important for us as we move on with our trig unit. But let's just focus here now. So I fill in the missing values with the variables. So 30, 60, 90 for number 6 means this is 2x, this side is x, and this is x root 3. For number 7, this is a 45, 45, 90, so I have x, x, and x root 2. Number 8 is a 30, 60, 90 again, so I have x, 2x, and x root 3. Okay, starting on number 6 here. I use this equation that it gives me to solve for x, so I divide both sides by 2. That gives me x equals 1/2. So the short side is 1/2, and the longer leg is root 3 over 2. Okay, so 1/2 times root 3, I can just write that as root 3 over 2, okay? And that's just something we want to do because, partly because this comes up a lot, this root 3 over 2, especially in the next unit of material that we're talking about. So write it as root 3 over 2. It's still correct if you do 1/2 times root 3, but root 3 over 2 is what you'll see as you move on in future math classes. It'll be just shorthand written like that. Okay, so number 7, I have 1 equals x root 2 as the equation that I can work with. So I use that to solve for x. Dividing by root 2, I get x equals 1 over root 2. Okay, and multiply top and bottom by square root of 2. That's just like multiplying by 1, remember. But this is useful because it gets rid of the square root in the denominator, right? Again, I have root 2 times root 2 down here, so that just gives me 2. Okay, multiplying across, I get root 2 over 2, so both side lengths here are just root 2 over 2. Okay, number 8, you might notice looks very familiar. It looks very similar to number 6. Okay, you see it's a congruent triangle to number 6, but it's been rotated 90 degrees and reflected. So we should get the same values, but we can still work through the process the same way. We start with this equation. So I have 1 equals 2x, divide by 2, I get x equals 1/2. Hey, so the short side is 1/2, and this side is root 3 over 2. Okay? Okay, so moving on, these are very important, okay? Again, this is kind of the foundation. These three triangles are the foundation of where we're going to move on from here. So make sure you have these ones written down. Okay, moving on now to SOHCAHTOA. Okay, so I mentioned we were going to review that today as well. Remember, these split up. You may... sorry. This would be our triangle that we're referencing, just a general triangle, general angle. This sign there that's marking the angle is called theta. Not sure if you should have heard that before in geometry, but in case you haven't, this is theta. And this would be the hypotenuse. If I'm talking about this angle, then this is the opposite side. It's the side that it opens up to, so that would be the opposite side. And the adjacent side is the side that's kind of included in the angle. Okay? The hypotenuse is included as well, but remember the hypotenuse is always the longest side. It's the side across from the right angle. Okay, so when you write SOHCAHTOA, depending on how you learned it in geometry, you might be more used to seeing it. Something like this might be helpful. Okay, so kind of writing the fractions in there. I've seen that done before. So again, remember, this is just saying sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over hypotenuse. Okay, so something like that, or if there's another way that you remember learning it, just go ahead and do that here. Okay, and we want to practice finding these for the labeled angles. Okay, so these three triangles are the last three that we had 2 slides back. We found these values, right? We were given the one, and then we found the other 2 values. Okay, so now that everything's labeled, we can easily find sine, cosine, and tangent for all of these angle measures. So starting with 30 degrees, sine of 30 degrees would be opposite over hypotenuse. So 1/2 over 1, which is just 1/2. Cosine of 30 degrees, that's going to be the adjacent side over the hypotenuse. So root 3 over 2 divided by 1, which is just root 3 over 2. Tangent gets a little bit trickier here just because we have fractions. So the opposite side, tangent is opposite over adjacent, so we would have 1/2 over root 3 over 2. Okay, so we could practice remembering how to divide fractions here. If we have to divide by a fraction, we just multiply by the reciprocal. Here the 2's cancel out, so I'm just left with 1 over root 3. But I need to rationalize the denominator, so I multiply top and bottom by root 3. That gives me root 3 over 3. Okay, moving on to 45 degrees. This is opposite over hypotenuse, so root 2 over 2 over 1 here. Okay, and then, so that's just square root of 2 over 2. Same thing with cosine. It's going to be the adjacent over the hypotenuse, so that will also be root 2 over 2. Tangent is opposite over adjacent, which is just going to be 1 here, because those are both the same, right? We have the same thing. It's like 5 divided by 5 is 1, right? No matter what number you have, if you divide by itself, you just get 1. Okay, and for the last one, 60 degrees, we do the same thing. Okay, so sine is going to be opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tangent is opposite over adjacent. So for the sine, I get square root of 3 over 2. Cosine, I would get 1/2. And tangent, I do opposite divided by adjacent. So I have square root of 3 over 2 divided by 1/2. I multiply by the reciprocal, and I get the square root of 3 over 1, which is just the square root of 3. Okay, so these 9 values here are all really crucial to the rest of this unit. So Make sure that you have them written down and try to start committing them to memory. Okay, and good luck with the homework on this. Try your best, and I will see you tomorrow. Thanks.